I'm Anil Kumar sharing with you a very important test question on solving trigonometric equations. You can copy this question, solve, and then check with my answer. The question here is 2 tan x cos square x plus sin x tan x minus 2 tan x equals to 0, where x is between 0 to 2 pi. Now clearly you can see that tan x is common, so let us start by taking tan x as a common factor. And we are left with 2 cos square x plus sin x minus 2 equals to 0. Now we have kind of a quadratic equation here, provided we can write cos square x as 1 minus sin square x. Let's do that. So we have tan x 2 times 1 minus sin square x plus sin x minus 2 equals to 0. Now we can further simplify this equation. Let me use square brackets and open these brackets. So it is 2 minus 2 sin square x plus sin x minus 2 equals to 0. Now 2 minus 2 is 0. So we have tan x, and in this bracket we have minus 2 sin square x plus sin x, right? Since 2 minus 2 is 0, so that is equals to 0. Now we can take minus sin x as a common factor, so we get tan x, and I'm writing minus here, minus sin x I'm taking as a common factor, so I get sin x minus 1. Sorry, this is 2 sin x minus 1 equals to 0. You see that? So now I've got three factors for this equation, and so I've got different sets. One is that I have tan x equals to 0, then I have sin x equals to 0, and I also have the third factor, which is 2 sin x minus 1 equals to 0. So all these three are going to give me solutions for this particular equation, right? So now we'll find out all possible answers for the given equation in the domain 0 to 2 pi. Okay, so we can also utilize this space. One by one we will take them up. So let's begin by taking tan x equals to 0, right? So when is tan x 0? Now tan x and sin x, since tan x is sin x over cos x, tan x is 0 when sin x is 0. Is it okay? Right? So we kind of have similar solutions for these two factors. How to find zeros for tan x? What normally I do is I kind of sketch the sine graph. So sine graph for us is kind of like this, right? So we know these are the 3 points when sin x is 0. Is it okay? So we can write down here that our solution is that x is equals to, within a period of 0 to 2 pi, 0, this is pi for us, this is 2 pi. Is it okay? So tan x is equals to 0 or sin x is equals to 0 at x equals to 0, at x equals to pi, and at x equals to 2 pi. Correct? Now for the second factor, or you can say the third factor, what we have is 2 sin x minus 1 equals to 0. So let me write here 2 sin x minus 1 equals to 0. That means sin x is equal to half, right? Now when is sin x equals to half? To find that, we will look into, you can always use your calculator, find the reference angle. Is it okay? So the idea here is we'll work in this fashion. We can look into our special triangle, which is pi by 3, pi by 6, right? 1, 2, and square root of 3. Now this triangle, and sin x is positive half, that means all and sine. So these are the two coordinates in which we are looking for a solution, right? Now from here you can clearly see sin x is half for pi by 6, correct? So one of the solution is pi by 6, that is x equals to, and the other is when x is pi by 6 in the second quadrant, so which is 5 pi by 6. How do you get it? Pi minus pi by 6. This is pi, this is 5 pi by 6. Is that okay? Now that is how you get it. Now these are the solutions, correct? And I have shown you how to get the solutions. Anyway, when we solved our equation, we got 3 factors, and these were looking, so this could imply that sine x equals to positive half. And from these factors, we figured out these as our solutions. So we can write our answer now as x is equals to 0 pi or 2 pi and pi by 6 and also 5 pi by 6, right? So these are all possible solutions for the given trigonometric equations. I hope in this exercise you learn how to efficiently factor and then find all possible answers. These are different techniques. You can always use your calculator, find the acute angle first, and then use your strategies to find other angles. But I find it very handy to use these simple tools to get to our answer. I hope that helps you. Thank you and all the best.